Hi everyone. Today we're going to review how to make graphs at Ledyard High School. Now, most of you have made graphs before, but that was last year, and so we think it's probably a good idea to review how to do it so that when you make your first graph this year, you'll get it right the first time or pretty darn close. Now, the first activity you're going to do in exploring physics this year is a lab activity where you're going to be taking some data and then you're going to graph that data and answer a question or two based on that graph. So for this is just a hypothetical example here. I made up these numbers, okay? These aren't from the real school or anything. But what we have is a data table about school buses that are coming to some school. And the buses are all numbered. Now, each bus drives a certain number of miles and it carries a certain number of students to school each day. And what we want to find out is there some kind of relationship between how far a bus drives and how many students it carries? Does it appear to be entirely random, or are we going to see some sort of pattern emerge from the data? Now, the first thing we need is a piece of graph paper. I copied this one off the internet, so we have a piece of graph paper here, and we have to have a title for our graph. So in this case, we are interested in the miles driven by a given bus and how many students it carries. So your title needs to describe the data set that you are making a picture of. It can't just be my graph or physics graph. It has to be more specific so that somebody looking at it can read your title and have some idea of what you're trying to show. And we also have our data table over here. Now, I don't know if you've ever heard this before, but a graph is a picture of numbers. And if you think of it in those terms, it may make more sense of why we make graphs. Because our brains aren't very good at finding patterns in a pile of numbers like this data table over here. But if we can find a way to make those numbers into a picture, our brains grasp that very well, and patterns will jump right out at us if we see those numbers in a picture. So yeah, we're making a picture of numbers, and this is the name of that picture. Now, the next thing we need to do is figure out what we're going to do on each axis here. Now, we have three columns of numbers. So the first thing we have to decide is which of these columns is relevant, which of these columns matters to what we're trying to do. And I think you'll agree that the column labeled miles driven, that matters, and the column labeled students carried, that matters as well. And the name of the bus really doesn't matter too much. So we're going to be making a graph of these two columns, miles driven and students carried. Now, normally we put the independent variable on the x-axis, that's the horizontal axis down here, and the dependent variable on the vertical axis. But with this set of data, there really isn't necessarily an independent and a dependent variable. So we have some freedom here. We can just kind of choose which one we do. And what I decided, let's see if we can get this thing going here. There we are. Okay, I've decided that I'm going to put the miles driven on the x-axis and the number of students carried on the y-axis. So we're just going to be consistent on this. Now, the next thing we do, once we have our axes labeled, is we have to make sure that we have some kind of units. So this one is the number of students, and it says it right in the title here. This is the number of students. So we don't have to put another note on here saying number of students. You can if you want, and that's totally fine to do. But if it's obvious from the title, you're okay. Same way with this axis, it turns out that since it's miles driven, well, there's our units already. So whatever numbers we choose here are going to be in terms of miles. So we have to have a name for each axis, and we have to have some sort of units, the names of the units that we're showing on each axis. Now, the next thing we have to do is put numbers on each one of these axes. And the way to do this is to see, well, how many numbers do we have to make room for? So let's look at the miles driven first. And our data set goes from roughly 0 to, well, 16 is the most. Okay? And it turns out when we count these squares, there's 25 squares here. Now, if we make each square count for 1 mile, that means that we have to have room for 16 miles. And that will fit all the way over to about here, where I have the cursor. And that will fill up most of the space that we have. It's not like all our numbers are going to be jammed over and crammed up on the left side with miles of open space. If we make each square count for 1 mile driven, most of the space of our graph will be filled up. So in this case, making each square count for 1 mile, that will fill up our graph pretty well. It's important to space these out so that um, we have most of the page filled. The bigger the picture we make, the more detail we can see and the easier it is to pick out patterns. Okay, now what about number of students carried? Again, we have to look at the number of students we have, and we have 52 is the most students we have. 52 is the most students we have. So we want to make this axis go from 0 and make room for 52. But we have to consider how many squares we have. And on the vertical axis here, it turns out we have 20 squares available to us. So if we made each square count for 1 student, there's not room for 52 students. We have to make each square count for more than two um, students. Let's see, I had a calculator out here and I want to get another one. There it is, calculator. Okay, we're going to get out a calculator. So the way to do this is to figure out how many students each square is going to represent. So we have 52 students. So we're going to say 52 students, and we're going to divide that by the number of squares that we have, which is 20 squares. So 52 divided by 20 equals 2.6. So that means that each square, if we make it count for 3 students, if each square represents 3 students, we will have room for all of the students to show up. So if we have 20 squares and each square counts for 3 students, that would be a total of 60 students that we could fit on our graph. 20 squares times 3 students per square would be 60, which means we could go from 0 to 60, and that's pretty good. Our highest number is 52. That's going to be up near the top someplace, so again, we're going to fill most of our space. So that's what we're going to do. We're going to make each square, let's see if I can fit this over here. I think this will be all right. Yeah, each square is going to count for 3. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Yeah, the numbers aren't really round here, but like 5, 10, 15, 20. But by going by threes, we fill up most of the space that's available to us. 52 will be right around here, 52, and that's going to use up most of our space. Okay, so when we put numbers on our axis, it's important that they be evenly spaced. So the difference between 0 and 5 is the same as the distance between 5 and 10. And we want to make each square count for the right number so that most of our graph will be filled up. Most of our page will be used, and we're not going to have acres of blank space. Okay, that's the hardest part, is figuring out where to put the axes. Now we get to plot the data. We have our data in our data table here, and now we get to stick it on here. I've already done a few of the first 4, but we'll continue on. So the next one is going to be 5 miles driven. Let's go to make a dot here. There we go. 5 miles driven and carrying 48 students. So that's 45 plus 3 is 48. And we're going to put a data point right there. Now, when you do this, you're going to be doing it by hand on a piece of graph paper, which is a lot easier, believe me. But this is the limit. This is what I have to work with, so this is what I'm doing. Okay, the next data point is going to be 9 miles driven and 30 students. So 9 miles driven and go up to 30. So there's 27. There's 30 right there. Okay, there's 30. And then the last data point we have is 16 miles driven, and we're carrying only 21 students. So there's 18 and there's 21 right there. See if we can make our little dot. Very good. Okay, so now we have 1, 2, 3, 4, 5, 6, 7 data points. 1, 2, 3, 4, 5, 6, 7. So we have them all on there. And we can see that there's kind of a pattern here. This is good. There's supposed to be a relationship between how far a bus goes and how many students it winds up carrying. Now we don't want to just go with dots. Excuse me. We want to try to make a line that will form a best fit between these. We don't just do connecting the dots from one to the other. That doesn't do us much good. We want to try to um, lay in a line here that will kind of even out the highs and the lows. So if we do it like this looks pretty good. We have about the same amount of space above the line to our dots as we have below the line to our dots. Um, and basically what you do is you lay a ruler through your lines. If it seems to be through your data points, you lay a ruler through your data points if it looks like they're forming themselves into a straight line. And just kind of draw the best straight line you can. And you can adjust this a little bit. If it looks like it'd be a little better fit to be a slightly different slope, that's fine. You have freedom in there when you're doing that to make your best fit. This is called the best fit line. Now, if you have a data set where there's clearly a curve to it, they don't all line up in a straight line, then you have to make kind of a best fit curve that goes through them. So I'm just going to add a couple points here. Like if more data points came out to be like over here and over here as we got more data, and maybe another one would be up here, another data point. There we go. Then in this case, a straight line doesn't fit so well anymore. I'll put this back out of the way so we can't see it, because now it looks like it's more of a curve, right? And in that case, you'd if you have a flexible ruler, you can kind of try to draw a curve, but you can just kind of do your best to draw a curved line that kind of goes through or close to the data points, and you make a curve, a nice smooth curve that fits through them. Again, this is a best fit line, but it's kind of a curve that goes through them. My hand's a little shaky. It's hard to do with a just mouse, which is what I have. But if you have a flexible ruler that you can kind of put a curve in there, or a French curve, something like that, then you can make a nice smooth line. And you might be able to make better predictions based on that. Now, the data set that you take in your lab, it may produce a curved set of data points, or it may produce a straight line set of data points. You kind of have to look at it and decide which it is, and then make the best fit curve or best fit line that is appropriate for the data. Again, you have freedom on this, and you can do the best you can with it. Okay, so let's wrap this up. What does your graph have to have? You got to have a descriptive title, and it has to have a title that actually says what the data is, not just my graph or Mr. Robinson's graph. It's got to say what you're actually making, what you're making a picture of, what numbers you're making a picture of. You have on the axes, you got to have labels for each axis and the units the numbers represent on each axis. Both of those are very, very important because it tells the reader, what they're looking at. And then finally, you have to have numbers on each axis, and those numbers have to be evenly spaced and spaced out so that you fill the page as much as you can with the data that's available for you. Next, you put on you plot the data. You got to do that neatly and as correctly as you can. And then finally, if it's a line graph, as opposed to a bar graph or like a pie chart, if it's a line graph, you draw a best fit line. It might be curved, it might be straight. It depends on the data that you're graphing on that particular day. Okay, so that's it. This is all the stuff. I'm going to finish with that page. So you have a list there, and you can pause this if you want, and you'll have a list of the things that you need for your graph. All right, thanks for your time, and good luck on making your graph. And I hope you've had fun on the lab that we did, or that you will do soon.